Hello, everyone, and thank you for joining us on your St. Patrick's Day. If you didn't know it, today is St. Patrick's Day. Hope you have your green on. Our conversation today is all about getting connected, the rise of robotics with respect to cellular connectivity. My name is Joshua Ness, and I'm a senior manager at Verizon 5G Labs. We're excited to host this discussion as part of our 5G Labs virtual event series. For those of you who aren't familiar with 5G Labs, we work with startups, academia, and enterprise teams to build a 5G-powered world using the practical application of emerging technologies. That's what these conversations are all about. If you're interested in learning more about our work, you can visit verizon5glabs.com. We also want to thank Allie for partnering with us to help make this event happen. Allie is an agency that unites rich and diverse communities around the country with corporate partners to provide resources to drive positive change in technology and in the broader world. Without further ado, let's introduce our incredible panelists who are with us today. We have a few amazing people. I'm very excited for them to introduce themselves and tell you where they're coming from. Chris Quick, you and I go back pretty far. Who are you and what are we doing here today?
I'm Chris Quick with Robotics, Inc. We're working on a software technology that allows you to connect humans to equipment machines. So think about a human remotely operating a robot. That's our core focus, building kind of software and hardware to make that happen.
Yeah, and you and I first met during the 5G Robotics Challenge that we ran in the greater Boston area a couple years ago.
You were the man that let me get my hands on 5G early.
It was a lot of fun. Dr. Nancy Lee, how are you? I know you and I have also known each other for a little while. What have you been up to? What's going on?
Hey, Josh. Great having me coming back. Yes, we met each other in Verizon, so my role has changed a lot since Verizon. So right now I am a director of product, a YouTuber, and product manager, coach, and also featured in Forbes recently. I launched the first 5G Edge product for Verizon about a year and a half ago in collaboration with AWS. And recently, I also helped Cox Communication to launch their version of developer-focused edge computing platform. And myself, on the side, I already started, I funded the product manager accelerator. So our goal is help people transition from worker bee to a product manager and business leader. To learn more about what I do and learn product management, technology, feel free to go to my YouTube channel, Dr. Nancy Lee.
Nice. And then coming to us from Oxford in the UK, Ajit Jalkar, how are you today?
Hey, welcome. Thank you. Thank you for inviting me. First of all, just to clarify, I'm actually in London because of the lockdown, because we are teaching remotely, but we hope to be back in Oxford hopefully later on this year. So I'm the course director of the Oxford University course, Oxford Art AI, Cloud and Edge. So it's a full stack AI course. It's very unique in that regard because we are looking at everything from the cloud platforms to sort of chips and everything in the middle. And it's a very technical course. And of course, we are very pleased to be working with the Verizon Labs. And again, I guess post-COVID, we are very happy to be in London in the Holborn Verizon Labs. Partly our course will be conducted from there for the session relating to 5G. And I think that I guess I'm perhaps more of a strong AI person than a 5G person. But I have, in a previous life, I was involved in telecom, so I have a pretty good sort of background of how that works. Cool.
Nice. Yeah, we're very excited for the Oxford course that's going to be taught about 5G and edge compute. Yeah. And we're excited for the launch of that and seeing how the London 5G lab is going to fit into that. And then finally, also from Verizon, Greta Knappenberger, how are you doing?
Hey, I'm doing great. Thanks, and greetings from Seattle, Washington. So I'm with Verizon, and I'm focused on smart city and our Internet of Things solutions. So we're covering all types of things, including the strategy, design, implementation, and operations for both enterprise and public sector across different verticals. So my main focus has been primarily around transportation, but we also are looking at manufacturing, energy and utilities, as well as other kind of key verticals. And just for context, most people know, think of Verizon as a network provider. Our 4G and 5G wireless networks and our vast fiber network do really lay the foundation of everything we do and everything that we work on. But if you think about, the combination of how Verizon's wireless and wireline assets enable creation of this whole network of endpoints at the edge. So think about office buildings, a smartphone, a robot on a factory floor, a city, a car, a drone, all the things that kind of form the fabric of our digital world around us. It's pretty exciting to think about, what I get to work on really extends far above and beyond the network. So we've got, our network, our platform, and all of our solutions that run above it that really help our customers. And, a lot of what I get to work on a day-to-day level is thinking about how we can help customers meet some of those key business outcomes and really think about what are some of the impacts, both from a societal perspective, as well as from an organizational piece. So I'm really excited for today to talk more about kind of our part in, reimagining IoT with 5G and all the kind of exciting things that go along with that.
Yeah, I agree. It's really interesting the way that that Verizon is evolving into this technology company that offers not just the connectivity, but those platforms and those end solutions like you're talking about that actually really show off the capabilities of what advanced connectivity can be. Before we kick things off, for everyone in the audience, please make sure to drop your questions in the Q&A feature. We won't have a formal Q&A at the end, but I will be keeping an eye on that and then weaving some of those questions into the conversation as we go. So just a real quick introduction of terms. I know Greta did a really good job of describing what we mean when we're talking about these solutions, that there is the connectivity layer and then the platform layer and then the solution layer. 5G itself, for anyone who is not familiar, is the 5th generation of wireless connectivity. And both in the way that it operates in the air, the spectrum, as well as in the way that it operates via fiber in the backhaul, the network itself is a fundamental transformation from what we had in 4G. And so the way that your devices on the consumer side as well as on the enterprise side, even the way that they connect into the network and the way they behave when they're in the network is changing and evolving and growing. And so when we talk about 5G, we're talking about lots of bandwidth and very low latency that makes for the much more complex end devices and client devices to be able to operate synchronously. And so a big component of that is the ability to access edge computing, which is essentially the cloud, which is where most data is stored these days. If you're looking at your phone right now, pretty much all of the data that you're going to call up on an application is located in the cloud, right? It's making a call out to a data center somewhere, and it's asking for that information to be brought back to it so it can show it to you or you can act on it, right? And with Edge, we're able to bring that cloud much closer to the end user, so that the data doesn't have to travel as far, and in some cases doesn't even need to leave the network, which has lots of implications for better security, as well as speed and agility of these solutions that we're talking about. And you might hear us throw around a phrase like CX to X, right? Now, when we do that, we're talking about the cellular connectivity of any device to any other device. Right now, it's used a lot in autonomous driving. You hear CV to X, which stands for cellular vehicle to anything connectivity. The way the ability for a car to be connected to lots of other types of devices that give it information so that it can act on that. And that's where a lot of those AI systems come in that Ajit can speak to. But really, in a 5G world, we're going to be talking about the ability for all types of devices, anything that you might think of in an IoT ecosystem, to be able to connect into the network and take advantage of those edge and cloud hybrid resources and be able to make decisions and function. And so that's one thing that we're talking here today, with a focus on things like robotics as they exist in these network ecosystems. So with that, I wanted to turn it over to Ajit first. How has this evolution of cellular connectivity been like in an industrial setting, and how did we get to where we are right now, and how has connectivity really enabled the rise of what you work on, which is these edge and cloud and AI systems?
Good. So thanks, Joshua. So in my view, of course, everything on the cellular side is the same but better. Yes, so effectively that you have connectivity even today for IoT devices, but you have proximity-based connectivity in most cases. We have some sort of router-like situation where you need to be near something, maybe with LoRa and things like that. That gets a little bit better, but you still don't have proper wide area connectivity. And that is what really 5G is providing us, and that's the sort of evolution in that sense. And then again, the two big things are the low latency and high bandwidth, and every G cycle of the network obviously has better bandwidth. So that's a given. But to me, the low latency is extremely exciting, partly because for the video applications and also for the IoT applications, because that's where I think most of the real-time like systems are going to go ahead with, and that gives us to the sort of enterprise applications of 5G, which is basically exclusively my concern, meaning that I do not look at the more the consumer side of that, and in that sense, there is a whole group of things which go along from there, and they are different from what existed before. So all the on-prem stuff, MEC, all of the edge computing, all of those things we kind of were not there in previous incarnations of network, and that's what's exciting. That's how we've come to this point. Yeah.
Yeah, it really is an exciting time for companies to begin adopting some of these. Greta, what industries have you seen based on your work with these platforms and solutions? What industries have been the most eager to jump at this new type of connectivity and this new type of solution?
That's a great question, and we're seeing kind of a whole range of industries. I think starting with manufacturing, as well as automotive, oil and gas, and agriculture, have really been the ones to kind of lean into adopting a lot of these types of technologies. And sorry, did you lose me?
We did for just a second, but you're back.
Okay, great. Hi. Yeah, so interestingly enough, the history of kind of cellular everything to anything or IoT really began with the invention of the programmable logic controller in 1968. I thought it was, I was pretty surprised to learn that it happened so long ago, but it was used by General Motors in their automatic transmission manufacturing division. So that's really allowed for the fine control of individual elements in the manufacturing chain. So starting all the way back in the 60s, they were starting to think about how do you start connecting these things? And then people began to explore the concept of network of smart devices as early as 1982, when a modified Coke machine at CMU, Carnegie Mellon University, became the first internet-connected machine. So a little fun fact for you today. And it really wasn't until around 1999 or so that the concept of Internet of Things first became popular, I think, at MIT. And that was just when RFID became a prerequisite for the Internet of Things. And so, at that point, if all objects and people in daily life were equipped with some kind of identifier, and computers can manage and inventory them. So that's kind of, going back to where we are today. And then the current conception of the Internet of Things really arose out of the emergence of cloud technology around early 2000s or so, which allows for the storage of data to examine all the historical trends and also enable secure and remote communication between devices and data sources without that need for human intervention and everything. So it's kind of interesting to see what, the history is going back. But, I think that where we are today, and I know there's a whole mess of technology acronyms that we're going to be throwing around today, both around 5G technology like 5G MEC and Edge, but even things like IoT, Internet of Everything, Industrial Internet of Everything, and now CX2X. I actually hadn't really heard that term before other than with C-V2X, with cellular vehicle to communications, but it's interesting to look at it from the conceptual perspective that, IoT, as you know, is a network of things like physical devices, vehicles, home, stuff like that are connected through the internet, which enables these things to exchange data. And then the concept of Internet to Everything really extends that. And basically it's more, where IoT is emphasized, the machine-to-machine communications, Internet of Everything describes a really much more complex system that also encompasses people and processes, intelligent connection of those people, process data and things and everything. And so now we're seeing the value of connecting the physical objects around us, like streetlights, parking meters, hospitals that occupy, our everyday urban lives, and all the, myriad of industrial applications like manufacturing and agriculture. And so kind of where I'm getting to is cellular IoT or cellular everything to anything really is just a way of connecting physical things like sensors to the internet by having them piggyback on the same mobile networks as smartphones. So it's really kind of like, the new version of IoT and everything, but it's pretty compelling when you think about all the use cases that are going to be brought possible that you now have this wireless technology with, low latency and high throughput to help with that. So back to the original question, manufacturing was probably the first one in there, but, as we're kind of evolving and growing and everything, I really do believe that we're going to see this, across pretty much every industry going forward. So.
Yeah, that's a really interesting way to think about it. And Chris, I want to jump to you. Just like Greta was talking about, how traditional IoT has just been thought of as machine to machine, but now with this Internet of Everything or a cellular everything to everything, we're really talking about being able to connect machines to humans, which is kind of where your sweet spot lies, and something that you've been pioneering for a little while now. So how have you seen that evolve?
So there's a couple ways. As a core technology, the idea of connecting humans to machines and making that a meaningful use case does come down to some of the core benefits of 5G, so bandwidth and latency. But the kind of game changers with 5G, at least from our perspective, is that it allows the things that humans have access to all the time, their smartphones, to have very high quality dedicated connections all the way down to equipment that could be anywhere in the world also connected. Where before we had our 3G and our 4G, and you could pull up your website or check your email a little bit, but you didn't have the capabilities to have live high bandwidth video and operating, say, a 6-axis robot arm to say get it back on path for operation to start up a manufacturing line. These are things now that you don't need to be in a special command center to pull off. You can pull your smartphone out and get that 5G connection and really make some things happen out in the world. So from our perspective, that edge compute and that high bandwidth and low latency have made everybody connected to the equipment we want to get them access to, and significantly lowered the cost to the average user of a system like that because it's reusing the hardware that we all already have.
Mm-hmm. And Dr. Nancy, have you seen any of this being accelerated in this past year, where this need for humans to be connected to other things in a remote fashion that need has increased? And so have we seen an acceleration in things like use cases and adoption?
Yeah, we saw lots of acceleration during COVID. And to be honest, COVID is a digital transformation for everybody. Specifically, I specialize in bringing intelligence into the connectivity. So once we have connectivity, what did you do? That's where the edge computing coming in. Let me give you guys several real use cases during COVID. So during COVID, we have seen a huge increase of demand, inbound demand of people in the industry start to talk about, well, now we're all watching Tom Brady's at home. Oh, by the way, I'm from New England. Sorry, we trade him off. But yes, when you watch Tom Brady at home for Super Bowl, and we cannot go to event anymore, but probably will, hopefully sooner or later, we can go back again. But how would you enhance the experience when you were stuck at home? You cannot go hang out with your friends, have fun, everything's virtual. But nowadays, for example, Zoom or Blue, the kind of old school, it's just boring because I've been doing that for years. So we have seen demand saying that how can we provide fan interaction? Yes, so you can connect everything in the stadium far away, and you can also connect things device at your home. What a new experience you can have. Let me give you specific examples. If you're going to do like real-time processing of fan betting on soon, like what's the score and how soon, what yard line like Tom Brady rank is going to have a touchdown, things like that. And this requires super low latency and also real-time compute, right? Because you need to do calculation and figure out, did Josh win or Nancy win? To get the result within like milliseconds, and Josh win like $1, Nancy win $1 million. I don't know, things like that. Yeah, so all of this require lots of compute plus connectivities, and fan wanted. People, we have seen demand, like all of whoever, especially in the media entertainment industry, say we want to do this for our fans, and our audience are willing to engage with us. So this is definitely a surge. And on top of that, think about this. When you watch this fan like stadium experience, if you have VR, AR goggle at home, of course, the VR, AR goggle need to be cheaper. How to make it cheaper, that's where the 5G and edge computing coming in. So I have a friend, he actually launched a Techstars like campaign or something. So his like device for the VR goggle, I think it's under $10, because he just want to lower the entry barrier of people getting into VR. And wow. Then your device, just because your device is so cheap, but how to make it cheap? Because you have removed the AI and all the fancy lenses out of the physical device, but into edge computing. But how would you connect edge computing? Is like 5G, like 4G LTE, something very advanced, like connectivity, so that when everybody's watching the game at home or doing anything, maybe hopefully in the future we'll have a 3D event like this, everyone watching at home, you can use the $10 device with like 5G plus edge computing, so you have much more advanced experience. And maybe we can see those like virtual questions you guys just submitted. I see several Q&A submitted already through those like display in front of you. It's like amazing experience people has been asking for during COVID.
Yeah, it's interesting that COVID has accelerated almost even more so the consumer use cases for some of these, which we had anticipated was going to lag significantly behind the enterprise adoption. On that topic of enterprise adoption, I'm curious about what 5G and edge computing means for industrial IoT and the future of work, and how we're seeing this transition. And specifically, Greta, curious for you, because one of the questions from Gary in the audience is asking about AGVs and AMRs, autonomous guided vehicles and mobile robots, mm-hmm. How those use cases they struggle with Wi-Fi, and how cellular is likely cellular combined with edge is going to be a much better solution. And so, what do you think, Greta, is holding back some of these organizations from starting to pilot these things?
Yeah, so I think kind of the combination of the technology and globalization of how what's going to be available depending on your location is really redefining and reinventing how the workplace and tasks are going to be performed, whether you're in a private kind of mech situation where it's more enterprise focused, or at a public mech where we're doing things outside in the city. And so AGVs is a great example in the manufacturing world. But that's a really good example of technology that is emerging, that's going to really enhance human capabilities and allow workers to provide a wider range of services remotely with greater efficiency and productivity, depending on what's available. And there's probably going to be a hybrid. I don't think it's only going to be 5G edge and mech. I think there'll be kind of a hybrid of the technologies that will allow, I learned a new word, cobots, which are collaborative robots that will be working together. And so some will be connected, some will be not. And then they'll be, depending on this, making sure that the standards are all kind of up to par, that they'll be able to talk to each other and communicate. But the workplace is constantly changing. As Nancy mentioned, I mean, COVID has really changed everything, and we're kind of in this midst of a digital transformation that's, more accelerated than anything we've seen today. Uninhibited by geographical boundaries, and, now with robots, new technologies, that, previously we only thought about in like the Jetsons or something. They're here, they're coming, they're really transforming kind of the way it works. So when you're looking at, an example in manufacturing, from the assembly line to the fulfillment center, automated machinery already plays a really vital role in the industrial processes. And the advent of 5G has the potential to really drive a massive change in digitizing these operations and, having this transformative impact on everything from production to inventory management to warehouse logistics. And with the automated guided vehicles, or AGVs, picturing them rolling through the production floor using computer vision, to autonomous industrial lift trucks that are helping move packages and stuff. They're all relying on equal parts strength and artificial intelligence. And they're really predicted to fundamentally change the way humans and goods navigate in a busy workplace. So I'm glad the question came up, and I'm sure there's probably more technical details we can get in between Wi-Fi and 5G. But in terms of some of the trends in self-driving vehicles, including AGVs, is definitely, one of the trends that we're seeing with Industry 4.0, along with things like remote maintenance, where people would be able to do quality inspection. It's outsourced and done remotely. And especially in times of COVID, that's one of kind of the key use cases and applications. Augmented reality is another one where you'd be able to do training and quality control, as well as kind of just general industrial automation and everything. And one thing we might touch on later is on digital twin technologies, where, for example, in manufacturing, oil and gas, you'd be able to test and simulate kind of a digital replica of the physical platforms and in virtual form without the need to engage in the physical or real platforms. So, for example, developing and simulating 3D virtual piping systems in oil and gas operations would enable you to test the systems in various conditions, to ensure the robustness of the system. So those are some of the examples we're seeing. I think, we're already seeing a huge shift in the, workplace of the future. And I think a lot of these things, including AGVs, digital twin, remote maintenance, all those things are really going to play a key part in everything to help augment humans, not hopefully replace them. So.
Right. And Ajit, how have you seen AI started to play a part in the growth of this industry and how it's being adopted in industry today?
Well, I think there are many areas where industry is making a big sort of IoT and 5G and all these things are making a big difference. And one of them, of course, is manufacturing. So I think that for us, that's where we see a whole bunch of the focus of our course when we combine kind of robotics with manufacturing with 5G. And most of them, from our point of view, are algorithms. So there's looking at kind of GANs, reinforcement learning, that type of thing. We also are working with a couple of very interesting companies, Arcturus, for example, who are Oxford-based, and they do sort of testing using robotics. So what that happens is that you create a very reproducible drug clinical trials situation with that, and then that's the sort of areas where we see a lot of work going on, which is more on the cutting edge of what we see, and all of that comes down to simple things such as the high bandwidth and low latency, and that just enables more applications to make them more real time.
And Chris, I imagine that helps out with some of the work that you're doing, and I imagine you have an opinion on both of those things, that those real time applications, as well as the idea that people are not going to be replaced, they're going to be augmented. And in some essence, we're looking at how people might augment the robots as well.
That's exactly right. I was just talking with a local manufacturer out here in Pittsburgh the other day, and they had told me they had an idle robot for about a year, and the main reason was they just didn't have access to a person that could manage it properly. The robot's set up to work primarily on its own, but it occasionally needs the help of a human. And so we're looking at a trial with that group to see if we can find them an individual that's out of their current geographical bubble and get them connected up with maybe a few folks that are able to give that robot a hand every time it slows down. It's kind of that same scenario over and over again that we get involved with. We have a different client that's actually in media production, and they have standard brick and mortar studio locations, but they've explored a rather large project with us in taking one of their whole studios and making all of the equipment remotely operable, so that their studio folks can, their director, their camera operators can remotely control a studio that they can now pop up in different places around the world where the people are that need to get the media created. So to us, the connectivity that 5G brings to the table, and making a lot of these applications affordable, because you're repurposing that edge compute for this application as well as many others, and it's not custom purchased hardware every time for one use case, is where we see the advantages.
So you're talking about a person who might be outside of this IoT or this CX to X ecosystem, taking advantage of cellular connectivity like 5G to be able to remote into that ecosystem and help it function. Is that right?
That's exactly right. That's folks like ourselves. There's was a factory at the beginning of COVID across Pennsylvania, and they needed a robotics engineer to help fix their stuff. They didn't have one locally that they could get a hold of, and so they contracted me. We did that with the use of this connected technology. So I could remote in, I could see the video from the robot, I could make some decisions, I could look at the rest of the hardware, and we were able to make that happen. And I'm not been a part of their ecosystem or in their geographical area. Without this connectivity, it would not have been possible for myself to be involved with their project. So you're exactly right. It's the people with expertise outside of that geographical bubble get this connectivity and can make things happen at a much greater distance. Sorry.
Yeah, I have a follow-up question. So I love your use case, and I imagine it's very useful during COVID, especially nobody even want to travel during COVID. Now maybe better. So when you talk about that use case, what kind of technology requirements is needed to enable that? I assume besides connectivity, there's also other setup. Just out of curiosity, how does it work?
So one of the major, key components is latency. And when you're trying to operate, a dynamic system, an industrial robot, motors and equipment, speed is absolutely critical. So when we're in a situation like how we're all communicating now, you don't know what the delay is necessarily when I say something and then when it finally gets to your ears. But if I'm controlling a robot arm in a factory, I am pushing a button and telling that robot to move somewhere, and then it takes time for that video to get back to me before I can make my next decision on what I'm going to tell the robot to do, maybe before it crashes into something. And latency is the key component that has to be minimized in order to make these types of use cases possible. That's the main one. The other one is bandwidth. So if you have an industrial robot or any device, you may want to see multiple camera feeds. We like to provide stereo, so 2 camera feeds that looking through your goggles, you are able to get depth. And that way you can tell how far away things are when you're trying to do a task like this. So if I'm trying to move the robot, 1 centimeter or 1 inch away from a pillar, I can't really tell what distance that is with only 1 camera. I need 2 cameras. And I need them at a low latency and a high resolution. So those are some of the key components required by the network. Then there's hardware in the field, but that's minimized by that edge compute. So you just have compute power out there. Sometimes our applications want to have augmented reality. So we want to put information on top of that video feed so that we can give feedback to the operating user about what's happening in that factory. To do that, you need processing power. And the best place for it is right there where the data is being generated, just like we were talking about earlier. And the key to making that happen is that edge compute capability. So I don't know if that answers your questions there.
Yeah, I love it. A quick clarifying question also for the audience. So I assume you're doing fully like remote control of the robot from your home with a simple joystick at your home, and the robot will move. Then you figure out what's the best way to enhance the robot. Am I right?
We can provide different types of control paradigms. Joysticks are one of the common ones. It kind of depends on what the end use case is, but you can imagine things. There's lots of folks playing video games with accelerometers in the controller or in your smartphone. So depending on what the use case is, we can, with the type of technologies that we're talking about, that low latency and that high bandwidth, we can actually take these sensors that are now in the hands of maybe the operating user, and we have enough fidelity with the connection that we can do meaningful things with those. So it doesn't just have to be a joystick or a keyboard or a mouse. We can use a 3D mouse or a combination of accelerometers, or some of the neatest and coolest technology that's coming out today is some of that touch technology. So if you've never experienced it, it will blow your mind, but you can feel textures through a sensor, across the world. And so if you imagine when you're trying to do something with the end effector on a robot, if you can kind of feel what you're doing and feel that pressure and that feedback, or even something starting to slip, you can imagine how much better control and capability you might have. Mm-hmm. So starting with joysticks, but moving all the way to kind of those future sci-fi use cases that we've seen for a lot of years. It's this technology that makes those real.
Awesome. Yeah, for the last technology you mentioned, it's called hyperstatic, something like that. And I think they talk about it in the remote surgery space. Hyperstatic, I forgot the name, something like that. Yeah, it's starting being used.
Haptic, I think you mean haptic, yes? Yeah.
Yeah. Very cool.
Haptic feedback. It's primarily been, I think, started from surgery and from the medical field, but it's rapidly over the last couple years started to become more affordable from a sensor standpoint, and then useful because of these other connection technologies that we're talking about. But some of the first use cases I think were through the Da Vinci robot for remote surgery applications. The major difference with a system like that is that's that super duper command center infrastructure that we were talking about, that was dedicated fiber connections between a hospital operating room and an operating doctor in some different part of the country. Millions of dollars spent to make that happen, where that sort of capability is kind of spread across the open air through 5G to your smartphone, with what we're talking about now.
Awesome.
And it's really interesting to think that it's really interesting to think that the remote surgery example is something that we've referenced even as a carrier industry. Verizon and a lot of the other telecom operators have talked about like remote surgery being like this thing that shows the power of 5G, but we all know that that's years away. But you're talking about something that is here. It's very close, where you could start having synchronous remote feedback, haptic feedback, and being able to perform activity using a robot in a non-surgical setting, in a warehouse setting, which seems much more accessible and much more real. Ajit, I'm curious, if we're talking about these enclosed ecosystems of connected devices and robotics, what needs to be true? Because if we're talking about somebody being able to remote in and have an impact on these enclosed systems, these bubbles of systems, if we're now expanding that to mean that a remote user can come in and have an effect on that, what needs to be true from a hybrid cloud edge structure? Like we're talking about completely rethinking an IoT ecosystem to be anywhere. What needs to be in place?
Yeah, sure. So I think that that's a very good question. And the whole idea of the hybrid sort of architecture is something we have been thinking about quite a bit, partly because of two reasons. The first one is because we are working on both the cloud and the edge. And for us, the cloud is mainly the three cloud providers, which is AWS, Azure, and GCP. And we basically take their APIs and then try to integrate those APIs with other things. Now, it all comes down to latency. Yes, so I think that there is latency with the 5G network reduces, and then there is a latency in the physical thing. Yes, so that is why you need the on-prem architectures to integrate with the same sort of flow with the network. And in practice, for us, that means things such as Azure Stack, which we are working with quite closely. It could also mean other products from AWS Wireless, Anthos from GCP, and so on and so forth. So for us, everything reduces down to pretty much things which we have API access to. And then we sort of start to build things into that. So I see that to be the future, because I think that that's where a lot of the innovation will come through partnerships with telecom operators and the sort of on-prem and sort of cloud and sort of hybrid cloud architectures. That's how we see the world in that sense.
Mm-hmm. And Greta, do you see the Verizon and the industry moving in that direction?
Yeah, I mean, Verizon's already, we announced some partnerships in the last year. One was with AWS, one was with Microsoft, and one was with IBM. And a lot of it has to do with how we can, manage some of these connections at the edge and enable some of these new use cases. And so one of the kind of focus areas is around looking at how do you use 5G AI and then like the 5G or IoT industrial solutions that are enabled with MEC or that's another acronym for you, the multi-access edge compute, and to be able to, use this technology to, see some of these productivity gains and have more efficiency through some of these different assets that are out in the field. So when you think of asset classes, there's about 3 or 4 that really, I think maybe could provide good, examples of the kind of problems that we're solving, with partners like IBM, for example, like industrial equipment, think power turbines, think power distribution, transmission lines. All of these things fundamentally need to be tracked and managed and maintained. And in many, of these industries like manufacturing, energy, utility, oil and gas type scenarios. So being able to adjust the balance between the energy generation and energy consumption will be needed in the future. So using things like massive IoT connectivity will play a key role when it comes to power grid balancing. That's just one example how we'll be able to get real-time information to balance and predict power consumption over time, and be able to partner with these different cloud providers to be able to use the big data analytics, the AI, and exchange information with other devices over the 5G networks and whatnot. Similarly, we're partnering with different cloud providers with smart cities, and that's another prime opportunity for the extreme coverage that we're going to start seeing with massive IoT. So think of the connected devices like water and gas and electricity meters, street lamps, even rental bikes that are now looking for reliable connectivity. For e-bikes and whatnot in a variety of conditions, both indoor and outside in the elements. So there's, different levels or requirements in terms of what is going to be needed to help support some of these different connected machines when we start seeing, a huge influx of massive IoT. And just one more definition for you. So for those of you who are not familiar with massive IoT, primarily consists of wide area use cases. So you're connecting a massive number of low complexity, low cost devices with long battery life and relatively low throughput speeds. So an example might be, temperature reading from a device in your home or business, or just a simple on-off application for a smart device and whatnot. Other examples are, smart buildings and asset and fleet management and smart meters and whatnot. But the ability of 5G networks with 5G Edge and MEC to support this massive increase in these low-cost devices, will be able to, result in a lot of, I guess, big opportunities for businesses using IT, for cities that are looking to expand and whatnot. So it's pretty interesting. There's a lot of really interesting use cases, but, from the massive IoT side to the critical MTC side, where we talked about the remote healthcare, traffic safety and control, and all these industrial applications, those are more where you need that ultra reliable, very low latency, very high availability connectivity. Whereas with massive IoT, it's more that low cost, low energy and whatnot. So, there's a lot of different requirements based on use cases, and that will kind of vary based on what you need to be able to scale up and scale down.
I would add just the APIs and the connectivity across some of these categories of the technology. So the cloud piece and the MEC piece, and then your mobile. What we spend a lot of effort today doing is we're applying these technologies to the use cases we've been talking about, and we're still spending a lot of time kind of building some of that core capability that is harnessing the power of these connections, and that all hasn't been streamlined. So it's great for all the developers and the technology companies, but I think as these things get created through necessity out of realizing these use cases, it'll also spread the use of the technology, because we will have open APIs, we have more software created to kind of harness these fantastic connection speeds and latency, low latency that we have.
Mm-hmm. And I think that what you're describing is that the companies and businesses will seek out, they'll begin to seek out the locations and environments for their facilities that have superior infrastructure. And I'm curious, are we going to start seeing, and I think, Dr. Nancy, this is a question for you, are we going to start seeing the shift from companies that are seeking out cheap labor to companies that are seeking out higher technology and higher capability facilities, because now we're starting to see where labor can be distributed? And so this gets to a question that came in from the audience. Kay was asking about how AI uptake in manufacturing might lead to a re-trending toward onshoring, where companies are bringing their facilities back into geographic areas in their domestic borders because of the technology capabilities. Because now we're able to almost reimagine where labor is and how it functions with the connected devices in there. And so, Dr. Nancy, as you're talking to some of your clients and customers, are you hearing any talk about this?
So definitely have seen lots of people reimagining their workforce, 200%. And big companies and small companies. And even now, if you talk to HR will have a new policy regarding how to work effectively using Zoom, and or like Zoom courtesy, something like that. Schedule 5 minutes in between Zoom meetings because you need to take a bio break and other stuff. So when we talk about the workforce shifting, yeah, for sure. For example, not just in the manufacturing industry, I think this is entire industry shift, like a movement. And for example, Microsoft already announced they let, at least for the product management team. Since last year, Microsoft let all the product management team to have the choice to work remotely, which means, see this, product managers are getting paid. I know lots of people salary because I help people negotiate salary. So just as an example, in fan company, product managers are getting paid 300 grand, right, per year. But that's in San Francisco. They're all in San Francisco, Seattle, everybody's there, and the house, everything very expensive. Cost of living is 30% more expensive than like Boston or other places, and then also much more expensive than New York as well. But if they can just hire the same type of product managers in Boston, New York, for 30% of the less salary, then they can pay in someone right in the downtown San Francisco or like Seattle, right? So people start to think about how can outsource certain type of functions which doesn't need to get into the office. Step one. And step two is that now let's talk about the manufacturing space. Certain type of manufacturing space, yes, if you can use remote workforce being connected through many different locations, and then you can just bring the best of the industry leader, just like Chris or whoever, anywhere you have in the world to help you solve some quick problems. And it's easier for you to reorganize your workforce, way easier. And actually the company itself is saving costs as a whole going down. And now here's a question, do we do it onshore or offshore or remotely? Do we still do manufacturing? I don't know, right now it's in Vietnam, right? Like, or you ship things to the US. That's something need more revolution in terms of how can we enable those kind of like technology, being able to connect globally. Because I know like 5G is more local. What if Vietnam manufacturing facility doesn't have the 5Gs, right? So the technology will definitely lead to more revolution in the manufacturing space, either onshore or offshore. But I will see things start to change even onshore immediately. It has happened already. Discussion is going on, so lots of excitement.
And so, Ajit, I'm curious what your thoughts are when we finally figure this out and when we start getting it right, when the infrastructure is laid down and people begin to take advantage of this stuff. Like, how do you see that impacting society at large? Like, how do you think it's going to be experienced?
Yeah, so I think that just to sort of take on the previous question and merge it with this one, I think then you can combine the sort of future of work and future of manufacturing to a certain extent driven by robotics. And the area which we are watching quite closely is goods to person. And I think goods to person, if you look at warehouses like Ocado and quite a few of the other ones now, they're kind of looking at this whole idea of reimagining what a physical warehouse distribution manufacturing plant looks like. And it's completely driven by robotics because you no longer have this idea of an assembly line like thing. Rather, you have these different sort of things which are being brought to a person physically in a space, and the person then does something with it. And it's a very fluid and dynamic workforce. Which is also much more educated workforce in terms of that sort of the role they're doing with that. So I think that is one thing we see with that. The second thing we see is this whole idea of sort of automation and the feedback loop with everything. Yes, so from an AI point of view, everything has some kind of a feedback loop, whether it's supervised learning or reinforcement learning. So we see this whole idea of self-learning things to be very relevant, because the big kind of limitation with AI primarily is that things are still having to be taught. And when I say taught, you mean you have effectively data to sort of model a particular situation. And now that has changed quite a bit with newer algorithms like reinforcement learning. So we work on something called Project Bonsai with Microsoft, again with AI, trying to understand how you can train machines faster. Using kind of some information captured by the algorithm, but also complemented by human skills. So I think all of these things are a continuum, meaning that the work will change, and as Dr. Nancy said, the nature and the location of work will change, and then all of that is triggered by all these new technologies and the networks. So it's kind of self-reinforcing thing. I hope that kind of answers the question best as I can. Yeah.
Yeah, it's going to be a brave new world.
Indeed, yeah.
To close this out, Greta, a question for you, and then Chris, I want to hear your follow up. Like, how do we enable this vision that both Nancy and Ajit have just laid out? How do we start facilitating this expansion across industries as a facilitator, Greta, and then Chris as an operator?
No, that's a great question. And I think, events like this are good to kind of bring together different viewpoints, because it's going to be a collaborative effort. So while Verizon is doing a lot, and like I mentioned up front, we're really laying the foundation of all the connectivity for all these different things. It really takes, a group effort and collaboration across across the different groups to be able to get these things done. That being said, when we're looking at some of the lower device costs and minimal power consumption and the massive increase in capacity that 5G is going to bring to the IoT technology, virtually every sector will be, orders of magnitude beyond our current LTE technology. There's already a large deployment of the IoT devices that are well situated for, to help with all of these different kind of use cases that can be enabled and everything. So I think being able to integrate this compute capacity and cloud services at the network edge, and then also tying in things like the robotics and everything, bringing to market a lot of these really transformational use cases that were really, previously untenable or impossible because of latent demands are really going to come to fruition. So we've talked around, manufacturing a lot. Transportation and automotive is going to be, really impacted, distribution and supply chain. There's a lot of, areas across verticals, across industries that are going to kind of start seeing a ripple effect on these things. And so, a few quick examples. I see there was a question around how 5G Edge and AI play a role in defense sector and game-changing use cases. I personally have been working more on like state, local, and smart communities use cases, but a lot of them will probably be able to roll over, and I'm sure there's a whole host of different really cool use cases at the federal level or with defense, but thinking about things with 5G power technology and solutions, a lot of, cities, states, and local municipalities will be able to do everything from, enabling vehicle to anything communications to allow first responder vehicles to communicate with each other and with civilian vehicles. And so using the power of our network to be able to connect from the vehicle to other vehicle to the network, vehicle to infrastructure, vehicle to everything, being able to help, with some of those killer use cases to be able to help, with first responders. There's a lot of really interesting use cases around increasing situational awareness with intelligent video and AI-assisted analysis and everything. And so I think that could also apply to the defense sector as well. And then being able to get those real-time or near real-time insights about, how things are moving, population movements, vehicle movement, traffic flow, all this based on de-identified or anonymized cellular data to be able to, connect people and processes and things all together and be able to, monitor some of these things. And really be able to get those data analytics to be able to see how, whether you're a city or you're in the defense sector or whatnot, and then on the, business side with manufacturing and logistics and whatnot to improve everything from safety to efficiency and whatnot. So I think there's a lot of really exciting things coming down. I know we're kind of coming up at the hour here, but hope we can continue this conversation going forward.
Yeah, I think it's going to be a good one. Chris, bring us home. If it's a 5G powered robots world and we're just living in it, what do we do to get ready for that?
So the approach we're taking, it talks to Greta's point. It's trying to get some applications in people's hands. So we're starting from actually the education side and helping out some colleges take their robotics equipment and get it connected online so that their students are able from their homes to still take that robotics class and get their hands on it. And then that skill is now directly applicable to controlling one of those robots with one of the clients that I had mentioned out in the field. And so it's kind of leading with an example, leading with a way that people are able to get involved, start from ground zero, and then apply it in real life, helping out, a client manufacturer in need.
It's going to be great. I can't wait. Thank you, Greta, Dr. Nancy, Chris, and Ajit for this incredible conversation, and a special thank you to our audience for joining in. This conversation has been recorded and will be available over the next couple of days. If anyone would like to share this content with their communities, you'll be able to find it on the page where you RSVP'd at, where you registered. And to answer one final question there, Vaughn in the audience wanted to know if you wanted to prototype this kind of deployment in a research lab setting, where's the best place to start? Check out Verizon5Glabs.com. We have labs all over the country as well as in London. where we focus on exactly that. So send us a message there, and let's talk about that. So we will be back here tomorrow at 2 p.m. for our monthly Mind the Gap event, where we highlight the voice of innovators championing inclusivity, representation, and progress for all women in technology. We also recognize that that March is Women's History Month, and we are excited to sit down with a phenomenal woman inventor, Elnaz Saraf, the founder and CEO of Roiby Robot. She'll be joined by Deepa Jagannatha, a technologist at Verizon, who brings over 17 years of experience in innovating and creating new inventions in telecommunications. It is sure to be a conversation that you do not want to miss. Again, that is tomorrow at 2 p.m. And you can register and get more information at verizon5glabs.com. That is it from us. Thank you so much for staying with us. Really appreciate all the questions. And to everybody who here on the panel, thank you so much. This has been awesome. I learned a lot, and hopefully everyone else did too. So we will see you next time.
Thanks. Thank you.
Yeah, thank you all.
Yeah.
Thank you all.
Bye.